Hello, welcome to Exo Photography. My name is Daniel. I have noticed something that probably you as well have noticed if you use a mount with a hand controller with a LCD screen. In the cold, you can't really read what the display says. The liquid crystals become basically frozen. And I use my phone to look out what object to observe. So why not use a Wi-Fi dongle? And because I like to create stuff myself using Arduinos, Raspberry Pis, etc. So why not make my own Wi-Fi dongle to my mount? So I came up with this. It's a ESP based Wi-Fi chip which I loaded some code into. So let's take a look at how that works. Okay, so I don't know if you can see this, but in the bottom we have a Node MCU version 3. It is a Wi-Fi based microcontroller connected to a RJ45 jack. And depending on what mount you are using, you could either use RJ11 or 12, but the RJ45 is what my mount is using for connecting the hand controller. So this box is taking place instead of the hand controller. I also have the USB visible here for easy upgrade. So let's take a closer look at how this is connected. We have 4 leads running from the mount. I will take a closer look at that one later. But the mount has 12 volts and ground. To power the chip, you need to step it down to 5 volt. So I have used a buck converter, in my case a one called Mini 360. From that you connect the 5 volt to the VIN, volt input, and the ground to GND. The leads for RX and TX from the mount is going through a couple of resistors and respectively to RX and TX on the chip. I found a lot of good documentation on both Stargazer's Lounge and Cloudynights. I will post those links in the description to the video. This schematics is from the GQ Direct RS232 TTL circuit diagram. Don't mind this one, but the most important is this one here. The ground is on pin 5 and 4 on the D-sub connector, 12 volt on pin 8, and RX on pin 6. TX is on pin 9. And this is the RJ45 male connector of the same cord. GND I associate to pin 1 and 12 volt to pin 8. Measure this with a multimeter, so you are quite sure of getting that one correct. If you mix up the TX and RX, the only thing that will happen is it ain't going to work, so switch them. But they have pin 5 and 6 respectively. In my case, I have pin 1 on the connector, ground 5, pin 5 is TX. I had a green cord that is connected to the ESP chip, to the RX, so TX on this one to RX on the chip, and pin number 6, the RX here, through a 47 ohm resistor to the ESP TX. I didn't have to use any resistor on the TX to RX cord, but I did have to use it on this one. So I soldered the 12 volt and the ground to a buck converter, to the ESP chip down to 5 volt, and then TX to RX on the chip, and RX to the TX on the chip. We're out here standing by my mount. Let's test this. So first of all, this one is replacing the hand controller, so that is what we're going to do first. So just unplug your hand controller, and this particular mount, as I mentioned, has the RJ45 connection. So just plug it in and turn the power on. There we go. And now we're going to start the app. There we go. SynScan Wi-Fi 123. Let's just wait till it is connected. Let's open the SynScan. There we go. Okay, so we are connected now. Just as the hand controller, you have a list of options here. So first of all, we can align, and we can choose from 1, 2, 3 star alignment, the bright star, etc. But we go with just 1 star. We can go with Capella and begin alignment. Okay, so it's going to slew, and there we go. I have no idea where Capella is right now, just pointed at some star. I don't have a scope mounted as well, so it doesn't matter. And it is the same procedure as with the hand controller. You are asked to center the star in the eyepiece or on the camera, and you have the ability to choose from the controls here. You have also a left and right arrow at the top of the keypad where you can change the slew rate, and you can hear the mount is slewing a lot faster now. Once we have centered the star, just press the star, and there we go, we are aligned. You can also check the sync samples and add more as you go. So you have a lot more control of the mount with the app than you have with the hand controller. You have the usual deep sky objects, you can search for them. You have the utility, the point and go, and that is with the phone. I have no idea when this is actually supposed to be useful, but star shows, I don't know. I'm going to cancel that. You have the tonight's best, the planet, the deep sky, the double stars. Polar scope, polar alignment, the periodic error correction, camera control. I haven't built in the camera control in this dongle, but hey, if you want to, you could. And you have the manual keypad as well. I'm not going to show you all of these settings, but it works flawlessly, and a ESP32 or a ESP8266 costs you about $10. RJ45 jack, $1. Couple of cables and 3D printed case. You can have your own adapter for well around $15. This is a small, simple, easy, fun project if you want to give it a go and start fiddling with the ESP. This is it for me. I hope this has been helpful. If you have any questions at all, just post them down below, and please like and share my videos, and you know the drill. Take care out there. Bye.